Okay. Good afternoon, ladies and gentlemen. We are going to start this, for me, very exciting session on zero carbon cities. So thank you for attending the session. Thank you to the speakers for coming from all around Europe in order to provide us with their privileged perspectives and views on this topic. I will start presenting the first speaker, which is Thomas Rauw. Yeah, Thomas Rauw from the Netherlands. He's working as an architect since 1990. Thomas established Rauw Architects and One Planet Architecture Institute think tank. He also founded in 2011 Turntoo, a company which is inspired by Cradle to Cradle movement. And Thomas is ranked number 18 of the top 100 Dutch key players in sustainable development. Thank you for coming. Then I would like to introduce you Joanna Williams. Joanna Williams, she's a senior lecturer in sustainable urbanism at the University College London. She's the author of the book Zero Carbon Homes, a Roadmap. Joanna is also director of the Zero Carbon Realities project and member of the working group setting up the Zero Carbon Hub for the Asian Pacific region. The third speaker is Mr. Emil Eriksen. He is the General Secretary of Active House Alliance, a non-profit organization working for development of sustainable buildings, focusing on comfort, energy, and environment, the three dimensions together. He has participated in several initiatives for sustainable buildings and COPs. And finally, but not least, Mihaela Thuring, with over 14 years of experience, Mihaela covered many aspects of organization processes. Currently, she's involved in the European research project, mainly focusing on actions meant to contribute to the transition process of cities towards efficiency and sustainability. Thank you again for being here. We will start with Thomas. You have 15 minutes, and I think that I love your title. Waste and energy are my own loves. So, thank you.
Yes, good afternoon. So after a long day, I hope that you still have some energy. It's 6 o'clock, maybe you're hungry. So I just take 15 minutes of your concentration, okay? So I cut down my lecture. I don't show you any architecture because you're full of architecture. And of course, as an architecture office, we made since 10 years, we made energy neutral buildings, CO2 neutral buildings, energy positive buildings. So this is not the problem. We can do this since 10 years. We can earn money with buildings. We just made a school where you earn 130,000 euro a year because the pupils are using the building out of freedom. And I come back. So I will talk about sustainable condoms. I will show you that the iPhone 6, maybe you know it already. And I will tell you that you can't buy an iPad. So these are my old laughs. So if it's an old laugh, maybe you're very happy that you get rid of it. So you can concentrate yourself on the next one. Or you go in therapy. So in fact, I'm quite happy. So what I think what we need is, we need new business models. So we don't need all the sustainable certifications. That means, I hope that works. Can you hear me? Okay. We don't need these sustainable condoms because that means we are certification that we're optimizing the wrong system. What we have to do is we need a disruptive, radical transformation. So we have to move out of our comfort zone, not just to make a little bit green and greenwashing and all this kind of energy stuff. Because the point is, what is the future? If you don't know what the future is, where you want to go? So let's talk about where we want to be over 7 years. Kennedy, he said that in '62, he said, we're going to the moon. Not because it's easy, but because it's very difficult. No idea how to get there. No idea if it's possible. What does it cost? But we just do that. So the point is, what is your moon? What is your moon in your business and what is your moon in your own biography? Because what you see is, We are here on vacation. You are the guests. After 60, 80 years, you're gone. Then you're in 80 years, we are all dead. Everybody in that room will be dead, and you know that for sure. So what does it mean if we are getting aware of the fact that we are the guests on the planet? So we have growing demands. We are more and more people. Now we have 7 times more people than 100 years ago, but we know this is a closed system. You just saw the planet Earth. Nothing will be added. That's it. We have to take care what we have. So if you live in a closed system, there will be limited growth, of course. So we don't have a crisis. We just on the border of the limitation. And that's what we have to realize. This is the future, because then we say, okay, there was something. Didn't we put something here in that mountain? So we are searching for copper, we're searching for iron, for phosphates. So if we want to describe the future, then we have to say shortage. But how comes? It comes because this is a telephone on the left side, and in the past we fixed all the stuff we had. We fixed it. My grandmother, he fixed it two times, 3 times. And then he said, yeah, now it's really broken, I have to buy a new one. And then iPhone 3, iPhone 4, 4S, 5S, 5G, and I have the 6, just a minute. This is the 6. It's a beautiful iPhone, and what you see, you're getting nervous. How comes Rao have 6? I don't have the 5. Did I miss the email? What is about the App Store? So you're getting nervous because you don't say goodbye to an iPhone 4 and to buy an iPhone 5 because it's broken. You're not interested anymore in the life cycle of a product. You're only interested in the performance cycle. And of course, the performance cycle is always shorter, normally, than the life cycle. So because of all the innovations and the linear economy, that means we're creating more and more waste. Of course, then we have the products on your right side. These are the products where the life cycle is shorter than the performance cycle. You just buy the printer, you go to the shop, you said, yeah, I know you just bought it, but you know, it's better to buy a new one. To fix the old one it's much too expensive. So that means this is a linear economy. So we think there are a huge of raw materials anymore, but it's not. Here, it's a limited system. But we organize it as it is not a limited system. So we take something from planet Earth, we make a product, we use it, and then we waste it. And then here, then on the right side, we have the recycling companies. These are the new shells. The recycling companies that just privatizing our capital, what we paid before. So to recycle means to optimize the wrong system. And anyway, we recycle always. The only medium which can leave the planet is helium. The rest stays here on that planet. And then the rest, if we don't need it, then we put it in the incinerator. Then we just burn it. So if we can't recycle, if it's too expensive, then we put it in the incinerator. And then we make green energy. So in this place, we burn forever something which will be never coming back on that planet. And we thought we have to change that. And then we have all these certifications, cradle to cradle, noodle to noodle, whatever it is. And then what you see, they pay a lot of money, but then it's come to the user. He said, okay, our cradle to cradle, yeah, very nice. Okay, yeah, okay, but what is in for me? So there's a leak because we have to change the relation between the producer and the consumer. We have to produce and to consume in a completely different way. Everybody has to get responsible for the consequences of his own acting. This is a problem in our economy. Nobody is responsible anymore for the consequences of his own acting. So to work in that model, we need 3 steps. First step is forget ownership. Focus on performance. Of course, if you're not a Buddhist, it's very complicated to say goodbye to ownership. But the Buddhists, they say, okay, I come with nothing, I go with nothing, and all the stuff in between, I don't need it. So what is about? But you know it, because if you decide to go from Barcelona to New York by plane, you don't look on the website of Airbus to buy a A320. So no, oh no, this is much too complicated. Just give me the performance flight. No idea if there's enough kerosene, if the captain is out of bed, if the steward is not sick, whatever. Just give me the flight. But you have a television. You know, the television is a kind of a poison bomb in your living room. And you are responsible for all the stuff in the television. And even you have no idea what kind of stuff it is. So that means you're not interested in the plane. You want to have a flight. You don't want to have a lamp. You want light. You don't want to have a chair. You want a seat. You don't need a washing machine. You want washes. You don't want to have a car. You want to have mobility. You don't want to earn the stuff. And you know, we started like this. Because the first advertisement in the world was performance-based. Genesis 1. There was someone, it shall be light. He didn't order a lamp, he just asked for light. So everything started with this and what we're doing right now. So that means if the user is not the owner anymore, he's just paying for the performance, who is then the owner of the raw material? The producer. So he has to take care for it, because he gets back the product after it's finished his service with the consumer. He's getting back all the stuff. That means if he produced shit, he's getting shit back. No certification. For what? It's up to him. That means we have to organize all the products like a raw material depot. This is the future. So something is, on the left side you see something is like a mobility service is sending out in the world, and it's coming back as a raw material depot. So what kind of component? What is the component's value? What is the product value? What is the raw material value? So nothing should be getting lost in the future. We have to take care of everything what is here. We don't have enough copper to make 30 million electrical cars. This is the first time in the human history that we don't have the stuff we need to make the stuff we want to make out of freedom. So what is waste? Waste is raw material without identity. If you have no passport and if you have no identity, you have no rights. It's the same with the raw material. If the raw material is losing his identity, it's getting waste. And the recycling companies, the only thing they do is they put an identity on the stuff, and then it's raw material again. So we have to organize the economy that we don't have waste. Waste is a world of the old economy. That means every product needs a raw material passport to know exactly what kind of stuff is in the product. So we're working with Turntoo. So this is an architecture of a new economical system. So we work as an architecture of a different part. This is our office. I asked Philip 3 years ago, you know what, I want to have 300 lux, 1260 hours a year. That's it. If you think you have to install a lamp for that, okay, I'm fine. And if you need water or white wine or red wine or electricity, I don't care. You need electricity to give me light. I don't. I have no energy bill in my office. That's the same. You can't buy an iPad. An iPad is an organized conglomeration of raw material. The iPad is an iPad if there's electricity on it. And who is so unbelievable stupid and who is paying the electricity for Apple so that Apple can deliver you the performance iPad? Ha! That's you. You are so stupid. The bill is for Apple. The bill is for Philips. It's not for you. Because then they earn the benefit of their own acting. So we do it with light, sit hours, table hours, walk hours, look through hours, separate hours, toilet hours, mirror hours. So we don't need any ownership. This is the first washing machine in Amsterdam. So now we're serving washes for the people in Amsterdam. And Bosch is saying, okay, but Mr. Rao, what happens if there's a problem with the washing machine? He said, yeah, then you have to fix it because you pay performance. He said, yeah, But you know, our business model, after 3 years, we need a broken water pump. After 5 years, the front door has to fall down. And after 6 years, we have to change the rubber. This is our business model. But if we are responsible for the acting, for the consequence of our own acting, we have a much better washing machine. We have one for 15 years. No problem for 15 years. But we didn't put it on the market. But now we do it. Because now we are responsible for it. You can do it with buildings. This is the first building in the world which is designed and made as a raw material depot. And of course we have a passport. Because the point is then, it doesn't matter how long we need the stuff, how long we use the stuff. If we need the building for 5 years, or for 20 years, or for 40 years, or even for 3 months, it doesn't matter. The only thing we destroy is energy, and we have plenty of energy, but it's for nothing. It's without tax, and we're destroying working hours. But you know, you sit here quite relaxed. Tonight you go home, said, oh, this crazy row, and then some of you is doing a meditation, some of you is taking a little bit wine, and then you go to bed. And you hope that you're getting awake tomorrow morning, you're healthy and full of energy. How comes that you are full of energy every morning? This happens to 7 billion people every night. They're getting loaded up without tax, without getting a bill. And that's a problem. And this kind of energy, this kind of energy we can use. So you see the old building here, and this is a new building. So they ask for 20-year building, and then we can take it away. This is a new terminal for Schiphol. This is also a terminal performance-based. So this is not a terminal, but it's a docking station for planes. So a plane is, sequentially, the planes are coming in, and then they come on a platform. It's a caisson. We just turn around the caisson, maybe 40 minutes or 60 minutes. So the people going out here we do the baggage, the kerosene, we clean it up, the baggage, the people, and then we go away again. So if we think the other way around, you come with completely different solutions. And the next step is material is service. We never buy any more material in the future. So I put some cards on your seat. So I wrote a book about material is service, how to organize the whole system completely different, not to optimize it, but to organize the system in a completely different way. Okay, my last sheet is, I started to tell you, we have to change this system. We have to transform it. We need a disruptive, radical transformation. And if you want to change the big system, my experience is the first thing you have to do is you have to transform your own system. To look after yourself, to see who I am, who I want to be. What is about my instrument? What is about my architecture? So if you take care for yourself, then you can take care for the business. And what you need is, the only thing to change the perspective is freedom. And the freedom is loaded up every night, 7 billion times a night. Thank you very much.
Thank you. Thank you for your presentation. Do you hear me? Hello. Thank you for your presentation, Thomas.
Yes.
Something is happening with my microphone. No. Thank you. Now it's perfect. Yeah. It's on, yeah. So thank you for your exciting and really inspiring.
15 minutes, eh?
15 and something more.
10 seconds.
More or less, yes. But what's time? Time is nothing. So, Joanna, please. The floor is yours.
Yes.
Wow, it's bright up here. Okay. Can you hear me?
Yeah.
Yeah. Excellent. I want to talk to you today about some research, a research project which took place over a 5-year period. It started out really looking at trying to find out how the UK could deliver their new zero carbon development policy. And it took me to a whole range of countries all across the world, but particularly in Europe and looking also at the United States of America. Now, during this period of time, what we were trying to do is we were trying to see how we could, I suppose linking back to the last talk, how we could create these transitions, these transformations within existing industries, so particularly within the energy industry and within the construction industry. And there certainly seemed that there might be potential for a cross-sectoral change between the energy and the construction industry if you brought in the right types of regulation at a national and international level. But what we also found, there wasn't really the guts for it, largely at an international and a national level, to bring in the type of regulation, the type of fiscal incentives that were necessarily needed to make that change happen. So we started to look more and more at the city scale, at the urban scale. And one of the places we looked at was Boulder, Colorado, where there is a smart grid system, as I'm sure you're all aware. And what was blatantly obvious as well was that it wasn't just about the technology, it was also about the social, cultural, institutional and economic frameworks which then supported those types of systems that made them successful or not, as the case may be. Now, we studied in detail 5 different cities. 4 of them were in Europe, 1 of them was in America, to see the types of factors that affected this kind of transition. We looked at the types of policies that local governments could introduce to encourage this type of transition to occur. We also looked at the different types of systems which we could introduce at local level. And we found that, contextually speaking, there was a huge variation. So there was massive variation because of the changes in the different local contexts. Having said that, there were common themes. And as a result of this, we developed, should have put this up ages ago, we developed 4 different types of tools, if you like, which could be used by investors, could be used by municipalities, to determine, for example, the types of cities which are likely to to transform over a period of time if you introduce systems into those cities. What we were looking at, cities where demonstration projects had been introduced, several demonstration projects often have been introduced, and to see whether or not those demonstration projects were scaling up. And when they were scaling up, we were trying to find out the factors that affected them scaling up. So all sorts of different things like leadership, things like public investment, but also it was about the clusters, the people, the actors that were actually involved in delivery. And it was also about the culture, the local culture. It was about the types of institutions that were developing alongside these new technical systems that were being introduced, and so on. So it was a very complex system that we were beginning to see develop in order to get these different types of technical systems off the ground, and something which was then spreading not only within the city, but spreading to other cities, essentially. Now, as I said, there were 4 different tools which were produced in this research project, which are also in the book that's been written as a result of the research project. The flyers were on the chairs when you came in. So one was we were identifying essentially what the different types, the most appropriate socio-technical systems were given the local context. So given the nature of the cities that you were working in, what types of systems were most likely to be effective. We're also looking at the factors which suggested that certain cities were more likely to be successful in that transition process. And finally, we looked at the different types of policies that could be introduced, types of tools, whether they be subsidies, taxation methods, regulation, or other softer types of encouragement through social networking and so on, that could actually help to change this process. And this is one example, which is the policy toolbox, and I don't really have time to talk about it, I don't think, here. Well, I'm not sure how much time I've got. But as I say, I can talk to you about it afterwards if you're interested, or any of the other tools, and it also happens to be in the book. Pardon? Oh, that was being shouted at. Okay, from the...
Sisplau, podeu posar el comptador? Habitació.
It's okay. marvellous.
Thank you.
Okay, so basically what we found was that lots of things. In addition to the actual tools that we were producing, there were two sort of key areas that came out that we thought needed further work, and we're now working on them. And one of them was that it was obviously very important that you get the people, the citizens, involved in the provision of the built environment. And this was to differing degrees, and we looked at lots of different models for doing that. So through co-building, for example, through community energy cooperatives. So that essentially the local people are actually involved in the processes of planning, designing, financing, managing, or possibly maintaining systems within their cities. Now, what on earth would be the motivation for them to do that? Obviously, it's much more convenient if we provide these systems for them and we operate them for them, particularly through the municipality and so on. But there seemed to be lots of incentives, and they were largely economic, but also social. There were fiscal incentives. They were financial incentives through the sort of the reduction in cost of energy and so on, but also through the generation of income through sort of community energy generation projects, for example. Building of social networks and also skills within the local community to actually be involved in design processes, in the management of energy and so on. Obviously, this kind of thing was also essential for things like smart grid to work effectively. It got the communities on board, particularly where there was a certain amount of distrust in the larger energy companies. One of the problems in Boulder, Colorado, essentially, was the level of distrust in the major energy company that was working there for smart grid. So essentially, it was looking at the different stages within the process that the citizens could get involved, whether it be through financing of these systems, energy systems, financing new build development, financing retrofitting within their own communities and so on, or whether it be designing, planning, financing, or managing essentially these systems. That was very important. The other thing that we found was that there was extreme difficulty, certainly for investors and potentially municipalities, in identifying places where this kind of transition was likely to occur. So where demonstration projects were potentially going to go beyond the demonstration project stage and scale up in the wider communities. And again, there was an awful lot of resistance within industry, or there potentially could be an awful lot of resistance within industry, even at a local level, without the right types of strategies being implemented by the municipality, and also having given the right cultural and economic context and institutions to actually support this. So what we decided to do, I don't think it's moving. That one? Sorry. It's not moving. Hurrah! Excellent. So, what we decided to do was a bit more, and we're working in this area now, a bit more research in this area. So on the one side, on the co-provision side, we're looking at different types of models which enable people, citizens, to become involved in energy, largely in energy and building projects, in the generation and the financing and so on and so forth, designing of those projects. And when I say different models in terms of how they work essentially with the private sector, whether they're entirely self-sufficient, or whether they also work with the municipalities as well and engage with sort of a range of key stakeholders in that process. It also investigates the policies and strategies needed to encourage that to happen, and sort of suggests possible tools for urban policymakers to encourage this to happen. On the other side, the side that I'm particularly working on, it's more looking at how you get transitions to happen, urban low-carbon transitions to happen within cities. And what we've tended to do is we've used variance models, which means that we've correlated particular characteristics of cities to determine how they might change the wider adoption of those systems within cities. And realise that this isn't terribly effective, because what we need to do, going back to what was being spoken about earlier, is we need to look at this in a more holistic way. to see how various knock-on effects within the city, where the tipping points are, where changes are likely to happen, what groups of people we need to get together to work effectively together. So looking at actor networks, looking also at the transference of knowledge within the city, looking at how the institutional structure has developed over a period of time in a lot more systemic way. And by doing this, we get a much clearer idea of what the processes are involved actually within that transition process. And once we know what those factors are, we can then start to identify the places in which these transitions are likely to occur. So I was sitting in a presentation earlier this morning with the European Union advisors talking about new research projects, new potential projects as well for investment in the future in the 2020 Horizon programme. And the key thing they're looking at there is scaling up and essentially how you transfer these ideas, how you develop the demonstration projects, move them forward. So this type of research, this type of systems understanding of how those processes occur and the identification of the tipping points within those processes and the factors that affect them is essential if you're going to start to identify where the future cities are with the greatest potential at this moment in time to change. But also, it gives municipalities greater understanding of what they'll need to do in order to become those cities. Because of course, this is not a static, but a dynamic process. And that's everything I have to say on the subject for the time being. Thank you very much.
Joanna, thank you for your presentation, and apologize for the technical problems. So now, from one project or research project, we move to another, to a presentation where Kurt will provide us with some methodological aspects and also with some examples of buildings, zero emissions buildings.
Yes.
That's true?
Yes.
Okay. So the floor is yours.
Thank you. So does it work now?
Yeah.
Okay.
I think so.
Yes, it does. Thank you very much for inviting me here today, and thank you very much for joining us this late afternoon. I shall talk a little bit about Active House and what Active House is, and I will run you through the philosophy of Active House, and then I will end up with some examples about what it is. But first of all, the background for starting up a network called Active House was that the European Commission came out with some very ambitious targets for 2020. And we realized at that time, or we were a number of partners in the construction sector, which at that time realized that we now have to go out and prove that we can build those buildings that the Commission is asking for already today with the technology that we have. We know that 40% of the energy are used in buildings and 36% of the CO2 emission comes from buildings. But we also have to be aware that 90% of the buildings that we have today will also be there in 2050, and therefore we need to focus on renovation. However, we also have to focus on comfort in buildings, because we spend 90% of our time in buildings, and 30% of the building stock today do not create a good indoor comfort for the people living there. And then global issues or climate issues, they are global. And that we also heard earlier today that we have limited resources, and we have to take care about the resources that we're using, and we have to focus on how we are using them in the building sector. So that was why a number of companies moved together to try to make a methodology that could take care of all the three topics: better comfort in buildings, energy efficient buildings, carbon neutral buildings, and a way of using the material which was based on environmental evaluations. So we started focusing on comfort, and we said that we need to make a methodology that shows that buildings are good and healthy to be inside. We need to make a methodology that shows that buildings are energy efficient and that they are carbon neutral and that they meet the future requirement for buildings. And then thirdly, which we also heard earlier today, we have to focus on what kind of materials we are using and how we are using them, and therefore we also in the future need to look at life cycle analysis and life cycle costs of buildings. So those were the three things that we were focusing on: comfort, energy, and environment. We have made a specification, and I have brought a few examples of the specification here today. You can take them here. You can also download them from the internet. They describe how we think we should look at buildings in the future, and we try to classify them in 4 different levels from 1 till 4, where 1 is the best and 4 is very good, but not the best. We focus on comfort, energy and environment, as I mentioned, and we focus on daylight, we focus on thermal environment, and we focus on air quality when we talk about comfort. When we talk about energy, we are focusing on how to optimize the building to make it energy efficient, how to integrate renewable energy in the building in order to make the energy performance of the building 0 or close to 0 or maybe even energy producing. And on the environment side, we're focusing on the environmental load that we have from the building that we're using, the materials that we're using. We also focus on how we use water in the building, because that is an issue which will come up in the future as well. And finally, we focus on how we source materials. I will not run through this slide here in detail. It's just an example about that we within each of the areas within comfort have some specific requirement or levels that one need to try to reach. It's the same with the energy criteria. There we also have some levels that we need to reach. And finally, also with the environmental load, there we also have 3 levels that we need to reach. If we bring all this together in a radar, we can present it as you can see here, where we have a radar diagram where we have all the 9 parameters included in the presentation or in the diagram. And this is the way of for us to show how a building is performing. So we would like to move from only focus on energy and energy efficiency to focus on an indoor comfort level, energy efficient level, and environmental level as well. The reason we started it up was that the Commission came out with some ambitious 2020 targets, but at the same time they also came out with a proposal of having legislation for nearly zero energy buildings, and we all know that we have to implement that by 2020 in all the European member states, and the Active House specification is a tool which can be used in that sense. We have made a number of projects which we have uploaded at our homepage. I will not run through those which we have there, but you can read about them on the homepage. Some are designed with the Active House radar as a tool. Others are built and evaluated later on. I will touch a little bit upon a few buildings. We have some buildings which are based on energy efficiency, which is made in USA and in Norway, just to show the wideness of where we are working. We have also focused on refurbishment, where there is a project in Germany which has been renovated to a carbon neutral level, and there is a project in Netherlands which we have renovated as well to a carbon neutral level at the same time also. And finally, there is also a public building, the kindergarten in Copenhagen, Solhuset, which a direct translation is Sun House, but I will come back to that now. Solhuset is a kindergarten which was designed by the local community, and they would like to make a kindergarten which was optimized in any of the 3 areas which I'm talking about: comfort, energy, and environment. And it was the ambition from the community that this house should show the future standard for kindergartens, and it shows it. The basic philosophy of the design process has been to use passive solutions as far as possible, using natural ventilation instead of mechanical ventilation. We have natural ventilation during summertime, and in the winter period we are using mechanical ventilation with heat recovery. We are using solar cells to produce the electricity to the heat pump that produces the energy. We are using solar thermal to produce the heat that are used in the building as well. The materials which are used are chosen from a maintenance purpose and from an environmental issue as well. So the surface is, for instance, made of wood, which can be reused afterwards as well. The design of the building was a triangle buildings, as you can see there, and normally if you have a big triangle buildings, it will be very difficult to get good daylight conditions in the inside of the building. And the architect started playing with how can I optimize the daylight condition in the building. And this was the first diagram that he presented. And after that, he started up moving around with the windows in the roof, and then he optimized the daylight in the building, and you can see that on the slide now. Where the building where the daylight conditions in the building are increased tremendously just by moving around with the windows. And this is one of the learnings. It is that if you already in the design phase look into comfort issues in the building, you can really optimize the building from a comfort level without increasing the energy use in the building with more. So it was a very good example. And the architect worked in 3 different levels with the design process, the daylight design process. And I will not go into details about it, but I would be pleased to discuss it later on. The energy performance of the building is that the energy demand is around 60 kilowatt hour, 55 kilowatt hour per square meter, which is not that high when you take into consideration it's all the energy which is used in the building. It's not only heating, it's all the energy which is used in the building. And then all the energy which is used in the building is supplied by renewable energy, which is solar cell, photovoltaics, and heat pumps. So if you, from the beginning, think about indoor comfort, indoor climate, daylight conditions in the building, you can really optimize a good building for the purpose of the people who lives in the building, and for this sense, children playing in the building. Another project which just opened recently in October in Canada is a great golf active house. It's an investor who would like to build a future building, and he wanted to optimize it in any sense, both within energy, within comfort, and within environment. This is the radar diagram for a standard building in Canada, and the architect and the designer and the investor said, we need to do this much better. We need to prove that we can build much better buildings based on the philosophy of active house. And now you can see how the design ended up for the architect. I'll try to move it back again. Here you can see how the design was optimized by the architect and the investor, using those 9 parameters to optimize the building. So he got much better daylight conditions inside the building. He got much better comfort. He got an optimized energy of the building, and he also focused on what kind of material he used. So in this sense, he used the specification to use the specification in the design process. And that is something that I think we should discuss in the future as well. How can we convince investors in investing a little bit more in their building in order to make it good and comfortable and also valuable for long term? This is the entrance to the building from the outside. This is a few pictures of the indoor comfort and the indoor climate in the building, and it's very well lighted building. I have the pleasure to go and see it myself 2 weeks from now, and I'm looking very much forward to see it. The energy system that he used, just to show us an example about how you can optimize a building if you already in the design process thinks a little bit about it. It's the wastewater system. There's always heat in the wastewater that runs out of a building, and he installed a kind of a heat recovery system so that the water which run out of the building, he takes the heat out of that water, and then he uses it to preheat the water in the building. And that's the kind of things that we have to look into in the future as well in order to bring the energy consumption down. We have a homepage where we upload the different projects, and you're mostly welcome to download the specification and other projects from the homepage. You can also subscribe to our newsletter and be informed and updated from there. And if you have some projects that you would like to upload, the homepage is a shared homepage, and you can also yourself upload projects on the homepage if you want to share them with others. I have mentioned the specification. There's a few here for those who are interested. Others can download them on the internet. You can subscribe to follow our work on the homepage, and you are invited to do that. And with those words, I will say thank you on behalf of the members of the Alliance, and I'm looking forward to a good discussion later on here today. Thanks.
Thanks, Kurt, for your very practical, very illustrative presentation. I think it's important to also to see clear examples of active houses and zero, low emissions houses. So thank you very much. And finally, Mihaela Thuring from the Flemish Institute for Technological Research will come back to the project level, and she will explain us a package of tools for integrated multi-criteria energy impact. Okay?
Yes.
So the floor is yours.
Okay, I hope you hear me well, because I don't see you very well because of the lights. Thank you for staying so late. This is the last presentation, so after that we'll just enjoy a small discussion. And I will present you now a package of tools that we created with the purpose of also helping the transition process. As it was mentioned before during this process, the design of new energy systems for urban district requires an integrated of multi-energy flow considerations. This presentation is about the challenges to bring together knowledge from various fields in a new toolbox relevant for the stakeholders. As we heard before the presentations of our colleague from London, there are several initiatives that are trying to find more ways to put together tools, instruments to ease the process of transition of cities towards sustainable cities, not to repeat the same path for every city every time. This is why we also tried another approach to bring together tools already existing within research institutes, academia, and businesses to facilitate this process. To start with, the starting point for our project, which is called the Live and Kicking project, is the KIC EIT-InnoEnergy organization. So the European Institute for Innovation and Technology is a body of the European Union, and I'm mentioning it because the audience is larger than the borders of Europe, so maybe they are not aware of all institutions and agencies of Europe that can get involved in funding different research projects or innovative projects. The mission of European Institute for Innovation and Technology is to increase European sustainable growth and competitiveness by reinforcing the innovation capacity of the European Union. It facilitates the transition from idea to product and from laboratory to the market. It's an organization very much oriented towards bringing to the market of products, of services, of tools, of whatever is already existing to ease the way to get it to the market, to the users. To do so, it integrates higher education, research, and business in area of high societal need through 3 knowledge and innovation communities, which are called KICs. I already showed 2 of the KICs, which is the climate change mitigation KIC and the information and communication technology KIC. And the program that the project that I will be presenting is developed under the KIC EIT-InnoEnergy, which is focused on sustainable energy. Okay, and the KIC EIT-InnoEnergy is a leading engine for innovation and entrepreneurship. To describe a little bit more about KIC EIT-InnoEnergy itself, it has 6 branches placed in various places in Europe, from Benelux to Spain. In Spain there are actually 2 branches. So one branch, CC Alps Valley, works on sustainable nuclear energy. CC Iberia works on renewables. CC Benelux on intelligent, efficient buildings. Sweden on smart electric grids and electric storage. Poland on clean coal technology, and the last one in Germany on energy for chemical fuels. And the project, I will start now, is developed under CC Benelux. So the general overview of the project is this project has 3 domains of activity. One, it's in relation with a new urban energy product, and we tried to develop and to bring to the implementation phase an intelligent light system. So under this project, software was developed which improved the, optimized the computational abilities of software in improving the way the lights are placed in the cities. Now we are talking at city level, not only at houses, because it's important also to have cities well illuminated. Another part of this branch was to have a sensor system which allows for reducing the energy consumption in the city for night illumination. So these are the systems. The first one is the computing system, which improves lighting, and the second one is about the presence detection, where the lights turn on different roads depending on the presence of users, passengers, bicycles. The second part of the project was related to urban energy service and comfort company concept. It's an ESCO company focused on refurbishing buildings and have a business model behind that allow them to have a payback time reduced in this way. The third branch is about the project is a little bit complicated because it has so many directions, but actually it tries to integrate different aspects in a city in a living lab structure and in a living lab using a living lab methodology, exactly to try to see how all these aspects in a city can be integrated. So the very last branch of this project relates to living lab. We have identified 3 types of living labs because, as you know, we hear all the time about living labs. The methodology of living labs integrates research and innovation process through a systematic co-creation, exploration, experimentation, and evaluation of innovative ideas. There are many living labs established throughout the world, and we try to sort out through the labyrinth of living labs, and we distinguished 3 types of living labs. The urban transition living lab with 2 distinct approaches, city planning and and district planning, urban citizen lab, and urban learning lab. Usually we are more familiar with the urban citizen lab, which is the type of living lab where the end users bring their input to different IT platforms, and the feedback that they provide helps improving the systems or brings this data into the system. But here we are focusing on a different level, which is the district planning. Our project will be at the district planning, because and the difference is that we no longer work with users, end users, but we try to work with project developers, engineering companies, architecture companies that are also some sort of users, but not at the very basic level. And we need their input to build this system. And the distinction between city planning and district planning is that the city planning is trying to help the transition process, and you can see the transition path through different steps. It tries to help the transition process from a top-down approach, governance or other measures, while in the district planning we see this help in the transition process from a bottom up. Okay, and so we try to build this living lab, and we try to address the city needs to meet their sustainable energy action plans. And these are examples of action plans that are in the systems. This is also in line with the research that was done for the ERA platform on joint program Smart Cities. Our aim in the end was to put together a number of tools from different organizations. So we have in our portfolio 10, worked for us 10 organizations, 4 universities, 3 research institutes, and 3 businesses. And we gathered from all these partners available tools and competencies that can address the city needs. And we looked at the tools that deal with city planning, environment, energy. And we gathered in total 37 such tools, and we mapped them, and we tried also to see what is the relation between these tools and the action plans. For example, we identified tools that can address specific action plans in hand. And here you see for lighting different addresses the action number 40, or other actions from hand. We identified, as I said, 37 tools, and we made also an analysis regarding the scale of the tools, the content, the possible interested parties, and the availability of the tools. And we narrowed down further, based on this, the number of tools to 12, and we included in this final package 12 tools that address the energy and CO2 reduction in buildings. And here I will have several examples of such tools. I will not go one by one through them, but you can download the presentation and see what it is about. But we have several tools on energy and CO2 reduction coming from various stakeholders. Okay. We're also on heating systems, which is very important to be integrated in the new cities, because it's an increased demand to integrate central heating at small scale or at larger scale. And also have on life infrastructure, as I mentioned before, and assessment at district level, where we have also a compass or sort of radar that looks at different aspects of sustainability of cities from social point of view, environmental, economic, and so on. But further works is necessary, because this project is a new initiative for KIC. So this package of tools still needs to be tested, to validate the tools, to look at the governance, because the governance can be in the form of an organization that oversees over all these tools, or an online platform. There can be various ways to deal with it. And we also have other projects that are trying to create, for example, an interface between tools to be used. Not necessarily these tools, but some other tools. And an in-depth analysis of the technical aspects to see what data are necessary and what data will come out, and how to integrate all this input for the different number of tools available. To conclude, an integrated package of tools can contribute to a smart city transition, but living pilots are necessary. And this is why EU initiatives are launched, but of course the organizational challenge is considerable. we hope that innovation that is fostered by KIC EIT-InnoEnergy will help the implementation of this package of tools. And of course, we are interested, if there are interested among you or other places, of possible projects where we can implement these tools and to see the outcomes and to see how to really improve the system to be able to scale up the transition process, and also to have a possibility to replicate the work in other cities. Because of course, big cities, big European or international cities may have funds to do research, but longer on the way, there might be also a lot of cities that don't have sufficient funds to invest in each tool one by one, and this is why we think that this philosophy of putting together a number of tools that they can look into various needs of the cities is a useful tool for a larger number of cities. This is my presentation, thank you. And with this we end the row of discussions.